In this video, we'll explore fractions as numbers. So fractions occur when we're looking at parts of collections or parts of items. For example, if we talked about eating 2/3 of a brownie or drinking 5/12 of a soda. When we're looking at that, we have to recognize that our fraction has two components, the numerator and the denominator. And our numerator represents the number of parts that we are examining, and our denominator represents the total number of parts in our whole. When we talk about a unit fraction, we're looking at a very specific type of fraction where our numerator is 1. And what this allows us to do is to look at what's it take to make all equal parts for this specific denominator. For example, if I have 1/5, that means I'm looking at one part of a whole split into 5 equal parts. Now, understanding this notion of a whole and what represents the whole is somewhat difficult for students, especially when they learn the beginnings of fractions because they've come from their whole number learning, which both in addition and multiplication. So what the first thing we have to do is help our students understand what is the whole of our fraction, because it could be a single object, like a pizza, or it could be a collection of objects, like the number of cars in a parking lot. So we help them understand not only what is the whole, then we have to understand the context of that whole and the question that's being asked. For example, in a question that we may ask our students is to take this shape and split it into 3 equal parts, so that we could say what's 1/3 of the area of the shape. Well, most students will split it in so that all 3 parts are identical, so that they have the same length, width, therefore the same area in all 3 pieces. However, depending on what we're trying to do, this third image is also correct because it does give us the same area in all 3 rectangles, even though the pieces are not identical. So we have to understand the context of the problem and understand what is the representation we're trying to have our students create. Improper fractions can also give students struggle because they have to understand what does it mean to have a numerator greater than the denominator, and how do we replicate parts more than a whole. For example, if we have 5/4 of pi, you have to recognize that that's more than one whole pi, but understand, okay, how do I get that next component that shows and represents that? First, we have to understand from our denominator what that means to be split into fourths. Then they have to recognize, well, how many of these fourths do I have? I have 1, 2, 3, 4. And I need a 5th one. So I have 1 whole pi plus a 4th more. And there, that can also help with the understanding of mixed numbers and improper fractions. Context of even understanding our improper fractions can be important as well. When you look at this image, do you believe this to be 7/8 or 7/4? Well, it all depends, because we have to recognize what is the whole in our picture. I could say that the whole is one rectangle, and that rectangle is made up of 4 parts. So if I look at that, I have 1 whole and 3/4 of a second whole, or 7/4. Or I could say that my whole is all of the squares that make up this image, and there are 8 squares, therefore 7 of the 8 are shaded in, 7/8. So understanding context of our images and understanding context of our problems is going to be very important. Now, even when we talk about just understanding fractions, we have to recognize that any single fraction has an infinite number of equivalent fractions to it that we can create. And that's somewhat of a complex idea for students as well, but it's a necessary one for them to be able to add and subtract fractions. So this notion that we can take and change 3/4 into 15/20 is quite complex. But if we think about it, we start with 3/4 of a shaded whole. And we say, how could we turn our 4 parts of the whole into 20 parts? Well, we would have to split each of those 4 parts into 5 smaller parts. And then we could see, by keeping our main components, that we have 5, 10, 15 shaded parts out of 20. So we could say that I know that I multiply my numerator and denominator both by 5 to create an equivalent fraction. And that is quite a large understanding for our students. And finally, the last component of this is that we have a lot of multiple meanings for fractions that students have to understand. And it takes a while for them to understand the differences in the different contexts that those meanings can have. We talk about it in a division problem when we start writing division problems as fractions, where, say, I want to share 24 M&Ms among 3 students. That would mean that each student gets 8 M&Ms. But we write it as a fraction a lot of times. We have the part-whole representation, where we have some relationship of one part to its whole, like 2 pieces of a pizza of an 8-piece pizza. We look at a ratio, where we're comparing quantities, like the number of balls that we have, where it's a 1:9 ratio between the red to white balls. And even ratios are split into rates, where we have quantities that have different units, like miles per gallon. And then lastly, as we get into the more advanced mathematics into middle school and high school, we start talking about fractions as operators. The notion of doing an equation of 3/4 x, and how would we graph that linear equation. So there's a lot of different moving parts when we try to get students to understand fractions that we have to be paying attention to help them make sure they understand the context, the whole, and the relationship we are trying to discover.